3, 2. All right, guys, let's go ahead and start. We're going to start by doing the derivative of e to the x. And I put in here that I'm doing an informal proof. I guess some will call it a formal proof, but this is an informal proof. So what I want, we have this property. And it's probably the first time you've seen it. So we're just going to take that as fact. If you were to type the equation e to the x minus 1 over x, you would probably see the limit as x approaches 0 to be 1. But we'll do that for another time. So I want the derivative of this guy. That's what this means, d dx. So I'm going to write f prime of x equals limit as h approaches 0 of, let's see, it's e to the x plus h minus e to the x over h. And right now at this moment, no one is scared, correct? No one is scared? Okay, good. So we're going to use some properties, some algebra properties. I can rewrite this as limit as h approaches 0 of e to the x times e to the h minus e to the x over h. And still no one is scared yet. They understood where that came from. Oh, sorry, miss. We're okay right now though, right? All right. All right. No, don't be scared. There's nothing here to be scared of. So now we see these, and in case you're wondering like what happened, why that, remember when you were in algebra 2, you had a to the a times e to the b. It's the same thing as e to the a plus b. That's all I did there. All right, so now I'm going to factor out an e to the x. So I'm going to rewrite the statement, limit as h approaches 0, and I'm going to factor out e to the x. And now I'm going to have e to the h minus 1 over h. And then we can use this formula that I said there, that equals 1. So I'm going to underline all of that right here. All that is just 1. So we found that that is just e to the x. E to the x times 1 is e to the x, correct? So we just did a proof. Nope, because e to the h minus 1 over h is 1. You know what I mean? Or no? Okay. So the derivative is just e to the x. So what am I trying to say? That the derivative of e to the x is itself. It's the only one that is like that. It is special. This is chain rule. Oh, okay. I didn't even realize that I had that down there. E to the x. If we do chain rule, here we go. It's just chain rule stuff. So e to the u is e to the u. And then take a guess. What do you think I'm going to put next to it? E to the u, no, that's the derivative of e to the u is e to the u. But I took the derivative of u with respect to what? Yeah, with respect to x. So what do you think I'm going to put next to it? Du dx. See, that's all it is, guys. That's all it is. So let's do, let's do this right here, example 1. And we're going to use that rule that we just learned right now. So it says if y equals e to the x squared plus x squared, I said that wrong, huh? If y equals e to the x plus x squared, what is dy dx? Okay, dy dx equals, the derivative of that is itself, e to the x plus x squared. Am I done? Times the derivative of x plus x squared, which is 1. There you go, and that's it. Leave it alone right there. If you want to distribute, you can, but I wouldn't. I would leave it alone. Now we're going to take the derivative of a to the x. Don't worry, guys. It's not that extreme. And I know that you see this right here, and that's because the only thing we know how to do is how to take the derivative of e to the x. So make a side note. Let's see, e to the ln of 5 is just 5. Everyone knows that, right? So if I have e to the ln of x, that is just x. So if I have e to the ln of x to the a, oh, well, actually, I want to do the other way, a to the x, that is just a to the x. Does everyone agree? Oh, because e and ln are inverses of each other. So they kind of like, they like cancel each other out. Virtual class, do you guys agree?
Now I do.
Cancel her out.
Okay. So you can test it by going to Desmos. Why does it work? Why is e to the ln of some power just whatever you have inside the argument? Because e and ln are inverses of each other, guys. That's why. All right. So why are they doing this transformation? Because all we know how to do is how to take the derivative of e to the x. That's all we know. So don't get confused. Look, this one right here is this step right here. That's just a to the x. And then if you move the x to the front, if you move this x to the front, you have e to the x ln a. So all this is still a to the x. We haven't even done anything. All we've done is algebra. We haven't done any calculus yet. Are we still okay? We're still okay, guys?
Yes.
Okay. Viacana, all I did was this. We have a, you see how I have ln of a to the power x? I just moved it to the front. That's the power rule for ln's. Okay. So now check it out, guys. I want to take the derivative of a to the x. So this is like taking the derivative of e to the x ln of a. I don't need to put parentheses there. Have I lost anyone? Have I lost anyone? Okay. This is still a to the x, guys. This right here that I'm circling in blue, that is still a to the x. It's just a transformation. Look, they're all equal right here. All right. Well, I know how to take the derivative of e to the x. E to the x is itself e to the x ln a times the derivative of the exponent. Now, ln of a is a constant. So what is x ln a? What's the derivative of x ln a? No, not 0, because I have a variable.
ln a.
ln a. Do you see that, guys, or no? No? Okay. Side note. What's the derivative of pi x? Pi. What's the derivative of ax, where a is a constant? A. Yes. What's the derivative of ln ax? ln a. It's just that the x is in the front. If you write it as ln ax, make sure that you put the parenthesis on the a, because it looks like x is attached to the a. Does that make sense? Either put the parentheses on the a or put a giant parenthesis outside the ln's, ln of a. So are we clear with this right here, guys?
So wait, so you said that like pi, a, and ln a, those are the derivatives because those are the constants, right?
Yeah, it's pi x, it's a constant. So the derivative of pi x is just, oh, I put x. It's just pi. The derivative of ax is just a. And the derivative of ln, and I guess I should put parentheses right here. ln a is just a constant. The derivative of ln a x is just ln a.
Okay.
Okay, so now that we've done that, here's all, remember, all this right here, that is still a to the x. So the derivative, d dx, of a to the x is just itself, just like e to the x, but this one has an extra step. ln of the base, whatever that base is, a. All right, let's do chain rule. Here it is, a to the u. So let's take a guess. What do you think the derivative of this expression is? A to the, yeah, don't say AU, say a to the u. ln of what? ln of u No, not u, ln of a. Am I done? No, one more step. Du dx, perfect. There it is. AU ln a du dx. How do we feel? Okay, so here we go. Example 2.
Wait, I'm sorry. Where did we get the LNA again?
From the derivative of x ln a, drop the x, it's a linear term. From right here, in blue. Because we knew how to take the derivative of e to the u. The derivative of e to the u is e to the u times du dx. Chain rule.
Okay,
Are we okay?
I think so.
We just need practice. No, there's not a song, but we can make a song. All right, so here we go. Now, I think that the way we did it, guys, I always think that teachers should be deriving these formulas. Now, we haven't derived all of them, but these I think we should derive, as you can see. And then now, are you going to be deriving them all the time? No, just use the formula. Just use that guy right there. So this is the formula. And you can just use it. But of course, we derived it. We derived how we got there. All right, here we go. At what point on the graph of the function y equals 2 to the power x minus 3 does the tangent line have a slope of 21? All right, if you do not have a calculator, this is how you would solve it. How do I know when my tangent line has a slope of 21? I got to take a what? Derivative. So here we go. Y prime equals, what's the derivative of 2 to the power x? Do not tell me x times 2 to the x minus 1. I see that all the time. You tell me that, I'm not even going to bother grading your exam. I can put 0. I'm exaggerating. I'm still going to grade it, but don't do that. The exponent is a variable. We just covered it. 2 to the power x. Am I done? Ln of 2, and if that x would have been x squared, then I would have said times 2x, but it's not. It's just so times 1, which is that. Cool? Everyone okay, guys? Okay, what happened? Okay. Correct. All right, you can write it times 1. All right, and now I'm going to equal that to what? 21. So now we're going to solve. And you don't have a calculator, guys, so we're going to have to do all this by hand. So 2 to the power x ln of 2 equals 21. I'm trying to solve for an x value because I wanted a point. So here we go. Divide by ln of 2. So 2 to the power x equals 21 divided by ln of 2. How do I bring that x down? No. I want to bring it down. How do I do that? I'm trying to solve for x. I can only if I use what? If I use a log. Instead of using log, I'm gonna use natural log, which is ln. So whatever you do to one side, ln of all this, you got to do to the other, ln of all of that. Because natural log looks prettier. I can use log. It's the same. I'll get full credit. But natural log looks prettier because I already have that lens in there. So I'm going to move this x to the front. So x, ln of 2. You don't have to put parentheses if it's just a number like that. On this one, I think you are forced to do parentheses. And then to get x by itself, I'm going to divide by ln of 2. Nothing cancels out. Don't even think about it. Nothing cancels out. The ln of 2 on the inside there is inside that argument. And if you were to expand it, it would just be ln of 21 minus ln of 2, and then close parenthesis, minus ln of 2. Yeah, it's going to look ugly. Here's it is simplified. Here's my x coordinate. Done. Leave it alone. On a question this ugly, probably not. How will we find y? You got to plug in this in there. Yeah, on a question this ugly, probably not. I bet you Delta Math will not have one this ugly. How do we feel, guys? Do we feel okay? Well, you just got here, so. Yeah, kind of. Yeah, that's all we're doing today. Just practice. Okay, I kind of want to continue. It's probably dangerous if you continue, because then you would just, yeah, because you would just be a robot if you just keep following. No, because we have to call back the functions. Should we stop here and have you guys practice just e to the x and a to the x on delta? All right, don't worry, Godinez. What's up? Maybe if they're fast enough. All right, let's come back. Let's come back, guys. So I want to take the derivative of ln x. All I know is how to take the derivative of e to the x. So I know that ln and e are inverses of each other. So I'm going to put e and e here. So now I have e to the y equals x. And now, what's up? You don't see why I'm doing this? And now I can take the derivative of this. What's the derivative of e to the y with respect to x? E to the y dy dx equals the derivative of x with respect to x. 1. So getting dy dx by itself, dy dx equals 1 over e to the y. But you don't want to see a y in there. I'm taking the derivative with respect to x. I mean, I guess that's okay, but I don't want to see it. So what's a better answer? One over what? 1 over x. So d dx of ln of x is 1 over x. See? So don't say that. You don't be a robot. You see where it was derived from. So chain rule. Chain rule. What is the derivative of ln of u? 1 over what? U times what? Du dx. There you go. All right. If f of x equals ln of x minus 3, find f prime and state the domain. Okay, the domain of the derivative is the same as the domain of the original function. So, does everyone know how this graph looks like? Oh, man. That's how that graph looks like, guys. Wait a minute. Notice that left to right, I am always increasing. Always, always, always. So my derivative better always be positive. My domain is x greater than 3. So when I take the derivative of this, here we go, f prime of x, 1 over x minus 3 times 1. There it is. And sure enough, if x is greater than 3, this will always be positive. It works. Perfect. Yeah, but one of the x's cancels out, and you'll get 1 over. You could also do ln of x squared, move the 2 to the front, and then 2 over x. You'll still get the same answer. Are we okay with that one, guys? Yeah, kinda? Bless you.
Wait, Chav, can you re-explain how you... I'm confused. Can you just like re-explain how you got that?
I got what? The domain? Ooh, remember this from pre-cal? I think we got to here. I think we stopped somewhere around right here. The change of base. So log base a of x is ln of x over ln of a, where ln of a is a constant. So the derivative is like saying d dx of ln of x over ln of a. Now remember, ln of a is a constant, guys. So I'm going to rewrite it. I'm going to rewrite it as 1 over ln of a times ln of x. I haven't done anything. I haven't done a derivative yet. 1 over ln of a is a constant. I can leave that alone. So here it is. Now I'm taking a derivative because I'm not going to write the ddx. 1 over ln of a times, what's the derivative of ln of x? 1 over x. So here's my derivative. 1 over x ln of a. Those are parentheses, but it didn't come out as good. So there it is, guys. So what is my derivative if I have a log base a of u? 1 over u ln of a, and then on the outside write du dx. Everyone okay, guys? A variable. This is, we're saying right here, look. And a differentiable function of x. All right, here we go, guys. I would probably state the domain first of everything. Remember, the domain of the derivative is the domain of the original. So 3x plus 1 must be greater than 0. 3x must be greater than negative 1. X must be greater than negative 1/3. That's my domain. I don't know if it helps you guys. I kind of like to rewrite it, but I guess we can just do this rule right here. I guess that's the whole point of this. F prime of x equals 1 over 3x plus 1, put it in parentheses, ln of what? ln of 2. Am I done? Times, what's the derivative of the inside? 3. So my final derivative for this one is 3 over 3x plus 1 ln of 2. You don't need that parenthesis on the 2, but you can. And the domain, there's my domain. All right. This you already know, but we'll do it really fast. You already know this. We'll do it really quick. This time your exponent is a constant. So look how simple this is. dy dx equals square root of 2 x square root of 2 minus 1. Done. It's not different. It's the same as power rule. It is the power rule because the exponent is a constant. Does that make sense, guys? All right, letter B, dy dx. Oh, did someone have a question, guys? dy dx equals, bring the pi down, 2 plus sine 3x. What power am I going to have in the top? Pi minus 1. Make sure that all of that is, I would put a parenthesis on it so that people know that it's grouped together. Am I done? No, times the derivative of the inside. What's the derivative of sine? Cosine 3x, and then the derivative of 3x is 3. If you want to leave it alone, I probably would. I would leave it alone right there. Is that the last one? That's the last one, guys. All right, everyone come back.